Hi Sundar Giri, Uh, am I audible?
Are you getting my voice, sir? Good evening, sir.
Good evening. Are you from BTech?
Okay, sir. Sir,
You're from
please,
BTech,
sir.
right? You're from BTech, na?
No, sir. I am from MTech, sir. MTech completed, sir.
Okay. You got this mail, right? That there is some class going on, right?
Yes, sir. Yes, sir.
Do you have any idea that anyone else will join or not?
No, sir. I don't have any idea, sir.
Okay. Okay, if anyone else joins, then we
Okay,
will.
sir. Sure, sir. We'll
Uh,
wait for some time, sir. For join. Okay, sir.
okay. You're from where?
Sir, I am from Andhra Pradesh, sir.
Angrao.
Angro, sir. Yes, sir. Bapatla. Bapatla
Okay.
campus. Okay, sir.
Okay, we will start after 6:05, right?
Sir, 6?
6:05.
Okay, sir. Sure, sir.
Hmm.
Okay, sir. Sure, sir.
2-3
Okay,
minutes
sir.
we
Thank
will.
you. Okay, sir. Sure. Sir.
Uh, Hi Sundargiri, I think we should start the class now.
Okay, sir. Okay, sir.
Okay, let me first introduce myself.
Okay,
I
sir.
am. I will let me present my presentation.
Okay, sir.
Is my presentation visible to you?
Yes, sir. Yes, sir. It is visible.
Mm. So I'm Sunny Kumar Sharma. I'm PMR research scholar from IIT Kharagpur, and I will be basically summarizing the NPTEL course of Professor Hibzur Rahman. The course name is Traction Engineering. You must be knowing this. So, uh, as the course is of 8 weeks, so I will also be covering 8 weeks, and per week I will take 2 hour class. So this is the first week, and I will summarize the content of first week. Uh, so the basically the contents of the first weeks are uh, here in lecture 1 we have concepts of traction and traction devices. In lecture 2 we have classification of wheels, forces and moments acting on the wheel. In lecture 3 it was tire construction and its specification. In lecture 4 it was tractive performance parameters. So I will summarizing basic concepts of this 4 lecture, and I will be giving you some questions. We will be having some question answer series. So
Sir, okay, sir.
hmm, so let's start with a basic introduction of this course. Uh, Mainly the main use of tractor, you must be knowing that it is used for pulling the implements. Sometimes off-road, mainly off-road and sometimes on-road for transportation. For pulling, we pull some implements like for some sewing machines or uh, some tillage implements, sometimes threshing for threshing purpose, and so on. So for pulling those implements we need to generate traction. That is the main purpose of the tractor. And from there we can also get a definition, basic definition of traction, which is nothing but traction is the way of a vehicle uses force to move over a surface. That is a basic, a layman definition of the traction. As we are increasing our implement size to increase the field capacity or field efficiency, basically field capacity of the machine. With that increased field capacity, we need to have a better traction. As to get better best that engine power. We have suppose 45 kilowatt, but we are taking only hardly 23 kilowatt, or suppose 30 kilowatt. Then the power that is wasted, that needs to be taken. And because that we will discuss that how why most of the power gets wasted. uh, then, according to ASAB standards, there are two types of surface contact devices. First is traction device, and second is transport device. In the figure, you can see that the rear wheel is a traction device and the front wheel is a transport device. Mainly, traction device is something which takes power from the engine and uses the support of the ground for its movement. And transport device just uses the support, it doesn't take power from the engine. That difference must be clear in this slide. And this is a ASAB 2015 standard in which how the power gets transmitted from the flywheel to the drawer is shown here in this diagram. If you have any doubt, you can ask anytime. I will be continuing.
Okay, sir. Okay, sir.
Uh, so from gross flywheel to net flywheel, and if someone else, you will not be knowing that someone else is requesting about you. Okay, that pop-up will come, I think. Okay, then from gross flywheel to net flywheel, uh, 92% power, 92% efficiency is there. From net flywheel and so on, from net flywheel to transmission input and to PTO, all the efficiencies are shown here in this diagram. From mainly the main thing you can see here that as we move from concrete to soft surface, uh, the efficiency which we get at the drawbar is is decreasing. uh, so as we move from concrete to soft soil, the efficiency is basically decreasing. And as we move from concrete and as we move from two wheel drive to four wheel front wheel drive to four wheel drive to track, the efficiency is increasing. That is a general observation which you can conclude from this diagram also. From engine power, we basically get three power outlets. First is power takeoff, second is hydraulic outlet, and third is drawbar. Here one thing must be noticed, that one thing must you can take note that drawer is the most used power outlet, and it is also the least efficient. And in this lecture series, our focus is uh, the power which we take from drawer only. So let us start that what traction actually is. I don't have currently that pad. I will I will be having it next week. So if diagram gets disturbed, then you please manage it. So if there here is a tire, and suppose it has some weight here. So the first thing after the tire moves, when the tire moves, is that it has some it gets some steering action takes place just at the interaction between tire and the soil. At as we have the as we have the shearing action at uh, at that initial phase only, we have a rolling resistance developed at the soil tire interface, and that action also gives the thrust required, the the, mm, the actual thrust required, with uh, and with the weight coming on it and thrust, we also get a ground reaction force. That is mainly the useful force generated to move the tire. And this rolling resistance developed, and the thrust which we get from steering action, when we subtract that thrust from rolling resistance, we get the pull generated by the tire. At when pull is zero, you can see that we have only we have no pull, and the thrust is there, rolling resistance is there, and the ground reaction is acting vertically upward. When pull is applied, the ground reaction is shifted, it is tilted, and we have a pull generated here. And the next part is factors affecting traction. First is soil parameter, in which the moisture content or bulk density or type of soil comes. Second is wheel parameter, in which the inflation pressure or the weight coming on the tire is considered. Third is operating parameters, in which the soil tire interaction, like interaction parameters like the slip mainly comes. For the total thrust generated by the tire is given by the equation AC plus W10 phi, where A is the contact area between of the tire which is in contact with the soil, C is the cohesion, W is the normal load, and phi is the angle of internal friction. When we have sandy soil, we have C equal to 0, and when we have clay soil, phi equal to 0. The importance of this the importance of this C050 is that when we have C equal to 0, this term is 0, we get all thrust from W only, as phi is mainly generally constant. So in sandy soil, uh, we have to increase weight to get more traction, and when phi equal to 0, this terms become 0, and C is generally a constant parameter, so we have to increase area of the tire to get better traction. From this diagram, you can also see, you can get your own you can get your clarity that when AC will be 0, this line will come here, and mainly we will be getting mainly the F we will be getting from increasing W. And when and when W 10 phi is this phi is 0, this phi is 0, this line will be straight, and we will be getting more F, we will be getting more thrust or maximum pull as we will move this AC upward. This thing I think will be is evident from this diagram. Uh, the next topic discussed in this lecture is the different types of traction devices. First is pneumatic wheel, second is solid or case wheel, one is towed wheel, and one is track type wheel. Pneumatic wheel is the mostly used Wheel, a common mostly used wheel in our purpose. Pneumatic wheel, which we see generally in our tires. Solid or case wheel are the wheels which we use for sometimes puddling purpose, and tote wheel are generally transport uh, or means bullock cart type wheels. Track type wheels are, you can see it is nothing but two wheels are with there, and it will be connected with a track. Coming to the next slide, let me check anyone else is there. Do you have any doubt till now?
No, sir, I don't have any. It's clear, sir.
I'm just summarizing the those lectures. I
Okay,
have
sir.
to
Okay.
I
I
have
have
to
some
just I have
basic
to
idea
just
about the traction terminology, sir. I have some basic idea about terminology, traction terminology, everything. So you can move on, sir. No problem.
I can move on, but I have to upload these lecture series. That's why I'm not stopping in between. This is actually
Okay, sir.
a part of PMRF TSC. I've told you this partner.
Sir.
Actually, I have to do PMRF TA duty of 2 hours. That
Okay, okay.
in general
Okay,
I have
sir.
to complete 50 hours of PMRF TA duty. This time they have.
Okay.
You know about PMRF?
No, sir. I don't know about this PMR, sir.
This is actually for research purpose. Government of India is giving. People were coming. I think
Okay.
Sivaram Viramuthu. So for PMRF is a scheme of Government of India, in which they are giving just enhance increased stipend to the research scholars. Generally, basically 70,000 in first year, 75 in second year, and 80 in third year and fourth year. So for that, they the PMR research scholars need to do TA duty of 50 hours, and to proportionately they have done it to 36 hours this time. So a part of that PMRF TA duty, I have taken NPTEL course of this traction engineering. So I will be uploading this course on YouTube. I'm just keep on presenting. At the time of question answer, I will be giving you assignments. I will be giving you questions, and you will solve that part. So for clearing that concepts, I'm just continuing. You can ask any doubts if anyone. You can stop me at that time if you have any doubts.
Okay, sir. Okay, sir.
Sivaram Viramuthu, are you there? Sivaraman, hello. At time of presentation, if someone is trying to enter in the Google Meet, I think I'm not able to get that message. Sivaraman, am I audible to you? So let me continue my presentation. Classification of wheel is the next topic. So wheels can be classified. Uh, so if you want to if you want to solve some questions, I'm presenting you a question. You can do that. Till then, I will be continuing my lecture for other peoples. You can solve this question.
Okay, okay.
You write down this question and you continue. When you are done, you tell me. You can take the screenshot. Have you taken?
Ah, yes, sir. I have taken, sir. Okay, sir.
Okay, you solve that question and get back to me. So wheels are mainly classified, can be classified based on flexibility, based on drive condition, and also based on construction. Based on flexibility, wheels can be classified as steel wheel and pneumatic wheel. Earlier, we were having steel tires only, but the steel tires has many limitations. It was very bulky, dumpy, and it gave a lot of sound when it was in working condition. For that, in 1930s at Nebraska lab, research were done, and when the pneumatic tires were invented, the fuel economy just increased by 45%, and it is just like it just like revolutionized the whole agriculture system. And based on drive condition, the wheels can be classified as powered wheel, self-propelled wheel, towed wheel, and brake wheel. This is an important and crucial part of whole understanding whole traction. If so, I will first explain what is powered wheel. Uh, In this diagram, first powered wheel is shown, then first powered wheel is shown, then self-propelled wheel is shown, then towed wheel is shown, and this side brake wheel is shown. So let me first tell you self-propelled only. Self-propelled wheel is nothing but it has torque applied on it, and it has no pull. The best example of self-propelled wheel is any car wheel or bus wheel or even tractor wheel. If there is no implement attached to it, the rear wheel acts as a self-propelled wheel. If no pull is attached to it, if a pull is attached, then it will act as powered wheel, which we will discuss later. In self-propelled wheel, the torque applied is just enough to overcome the rolling resistance, and the ground reaction is uh, acts vertically upward in vertically upward direction, and it is also you can notice in the diagram it is away from the center line of the tire. Then comes towed wheel, in which there is no torque applied. It is just getting power so that it can move. Means towed force is just equal to rolling resistance, and it is just moving. It has no torque applied. That this direction, and there is no torque in any direction, and the ground reaction is just is passing through the center line. In towed wheel only the ground reaction passes from center, and in no other condition. You can see that in powered wheel also, and in self-propelled also, and in braked also, their ground reaction doesn't pass from center, but in towed condition it passes from center. Then we have power bill, in which is of our purpose. Means when any implement is attached to the tractor rear wheel, the wheel is called powered wheel. In which there is also a torque, there is also a pull, uh, and the torque is applied in positive direction, and this total thrust minus rolling resistance is the pull edge. Brake wheel, and all the example I have given for powered wheel, self-propelled wheel, and towed wheel. Brake wheel is nothing but a powered wheel only, but the torque is in opposite direction. And the best example of this brake wheel is the ground wheel of seed drill. That is the best example of power brake wheel. And in detail, you can take the screenshot of this powered wheel and brake wheel, and this the in the diagram B, we have towed wheel, and in diagram C we have powered wheel. This diagram in detail we will cover in next lecture series. Is anyone else trying to enter? And based on construction, the tires can be classified as bias ply wheel, radial ply tire, and bias belted tire. Bias ply tire is shown here in this diagram. Radial ply also, bias belted ply also, and in detail we will cover in the next slide. Forces and moments acting on the tire are generally three forces and three moments. In x direction, we have tractive force. In y direction, we have lateral force. In z direction, this we have normal force. In x direction, we have tractive force, and the moment acting in this direction is the overturning moment. In y direction, we have lateral force, and the moment acting in this direction is the rolling resistance moment. In z direction, we have normal force, and the moment acting in this direction, z direction, is aligning torque. Coming to the tire construction, we have in tire generally we have tread, we have edge cover, we have sidewall, inner liner, carcass, steel belts, and the diagram is shown here. Bias ply tire, in bias ply tire we have this beads and this carcass, and uh, when this beads are this beads, suppose we have this center line of the tire. When this with the center line, this beads are making some angle. This is called crown angle. This is for bias ply tire. It is 54 degree, and these beads are at 90 degree in this radial ply tire. The difference between this was the geometrical difference, and mainly bias ply tire are in bias ply tire, side walls are relatively stiffer, and in radial ply tire, side walls are prone to cut, because in radial ply tire, this will get a deflection. This also gives a better traction in field condition. Bias belted tires are nothing but a combination of bias tire and belted tire. A belt is just there. When we insert a belt in this bias ply tire, we get bias belted tire. Uh, Tire terminology consists of the main dimensional part of the tire. From this diagram, this real diagram of the tire, you can relate uh, this schematic diagram, where this part, the section height, is shown here. This over this nominal rim diameter and rim diameter, and this difference flange height is also shown here as dash. Uh, this deflected when this is unloaded, this is in unloaded condition, and when we have deflection, the section height is called deflected section height. From the center line, when we divide the overall diameter, we get the radius of the tire, and when we subtract that radius to the deflection, we get static loaded radius. This is the tire designation, and the tire is mainly designated by its size, aspect ratio, type of construction, ply rating, pattern code, load plate, rim diameter, serial number, manufacturer's name, and collaborator's name, and company logo. This is a car tire, in which you can see that the designation are a bit different. The tire for tractor tire, I will be showing in next slide. For in car, generally we have P for passenger car. 215 is the nominal width, 65 is the aspect ratio, R is radial, and so on. Tire grading for radial tire. So first is radial tire, in which is designated as with when we have some R types R symbol in the tire, we can easily say that this tire is radial, and 18.4 is the section width. 46, suppose here we have this tire is designated as 18.4 R46. So first 18.4. Hello, Sivaraman. Hello. Hello, Sivaraman. Are you there?
No, sir. Yes, sir.
Ah, are you there?
Sir, I'm present, sir.
To can you calculate the overall diameter of this tire? Designated the designation is 18.4 R46.
Overall diameter, no, sir.
Ha.
Let me try, sir.
Try it is 18.4 R46. Do you know what is 18.4?
18.4 is the section width.
Section width in what, in which time, in which unit?
I think so. It is in inches, sir.
It is in inches, yes. You first calculate this inches to mm or any one unit.
Yes, sir.
This is section width, and generally aspect ratio if not given you have to take 46 75, but here aspect ratio is given in a standard, in a standard unit aspect ratio, metric unit aspect ratio is given as 80, means 80% is the aspect ratio, means generally you have h by b given, section height to section width given. When you multiply section width with this aspect ratio you will get the height of the tire. Aspect ratio is 80% and rim dia is 46. You have to you have to do all this in one unit. Suppose you are doing in centimeter, for you will multiply 46 into 2.4. You will get some amount, and that diameter you have to. Hello.
Sir, I'm present, sir. I'm listening, sir.
uh, from this section width you will get section height from this aspect ratio, and that section height you multiply by 2, and as you have two section heights for calculating overall diameter, and this rim diameter you will multiply by 1.06 because you have some flange height there. For compensating this nominal rim diameter and rim diameter we multiply by 1.06 because nominal rim diameter is designated on the tire, and rim diameter is somewhat bigger. For compensating that we multiply with 1.06, so you can do that, then you will get the radial tire. That problem is also I have given in the next question answer session. So if you are calculating then it's okay. And for bias ply tire, only R, if R is not designated on the tire, you can say that this is a bias ply tire. 13.6 is what? Can you tell? Can you say what is 13.6?
Uh, 13.6 is the section width, sir.
Section width, yes. And aspect ratio is not given here. So aspect ratio is
We should
75%
be
you can
taking
take.
aspect ratio as 75. Yes,
Huh.
sir.
And 28 is the nominal rim diameter.
28 will be the
Yes.
normal rim diameter.
And this and below that we have 12 PR nylon 128 A6. 12 PR is for ply rating. Ply rating and load rating, these are nothing but it designates the strength of the tire, mainly the load carrying capacity. And the star rating is how much is the inflation pressure the tire can bear. With every increase in the star rating, suppose we have 1 star, and we increase the star by 1, we are saying that the inflation pressure can bear is 6 psi more. Means 1 star is equal to 6 psi. Tractive performance parameters are the means gist of this whole traction series. So do you have any idea what is travel reduction ratio?
Travel reduction ratio is also known as coefficient of slipping, sir.
Travel reduction ratio is nothing but slip only.
Yes, sir.
What is slip? Can you say?
Mm, Without without your load, your travel can travel a specific amount of a tire can cover a specific distance, but with load, the tire cannot be able to cover that distance which is previously done without load, sir. So the difference between these two is referred as travel reduction ratio.
You said about loaded and not on unloaded condition, right?
Yes, sir.
I think you said you said this slip definition in terms of loading and unloading, right? That
Yes,
is
sir.
also okay. Means mainly. Hello. Yes, you are saying something.
No, sir, no, sir.
Yes, you are right. It is the expression is generally V theoretical minus. Have you seen this for this notation equation?
Yes, yes, sir.
Theoretical velocity
Yes,
minus
sir.
actual velocity by theoretical velocity.
Yes, sir.
So travel reduction ratio is due to the interaction between soil and tire. The tire doesn't travel due to the interaction between the tire and the soil. The tire is not able to cover the actual distance but it should cover. It has some shearing action between the tire and the soil. With that shearing action it gets slip, and uh, the actual distance is gets reduced. That reduced distance divided by the actual distance it can cover is the slip. This formula, can you derive that how this uh, came? Theoretical velocity minus actual velocity by theoretical velocity. According to definition, what I said, the distance covered without load, as you were saying also, the distance covered without load minus the distance covered with loading condition divided by distance covered with with unloaded condition. When you will do the distance covered is what? Is anyone trying to enter? Hello, Sundargiri. Sundargiri, can you tell what is net traction ratio?
Actually, I don't get remember.
Net traction ratio is actually the pull, the total pull, which we discussed earlier in this slide. I was telling that this is the thrust that which the tire generates, and this is the rolling resistance. This thrust minus the rolling resistance, this thrust minus this rolling resistance, in when pull is applied, we get some pull, which is nothing but thrust minus rolling resistance. This pull is divided by the dynamic weight coming on a wheel, is the net traction ratio. This pull by W is net traction ratio. This rolling resistance by W is the motion resistance ratio. This thrust, total thrust developed by the tire divided by the dynamic weight coming on it, is the gross traction ratio. This pull by W is net traction. This T by W is gross traction ratio. This rolling resistance by W is motion resistance ratio. Can you explain? Can you repeat what I said? Sudirgiri?
Yes, sir. Yes, sir.
Uh, P by W is what?
Sir, your dynamic load with the rolling resistance divided with rolling resistance is the net traction ratio.
No, no, no. Rolling resistance with dynamic weight is motion resistance ratio. It's not net traction ratio. Net traction ratio is pull by W. Net pull.
Okay.
Net pull divided by dynamic weight is net traction ratio. Rolling resistance divided by weight divided by dynamic weight is motion resistance ratio. And thrust divided by weight is the gross traction ratio. The total thrust generated by the tire.
Okay. Okay,
Is
sir.
it clear?
Yes, sir. Yes, sir.
So travel reduction ratio or slip is the reduced velocity due to loading condition, due to the shearing or some shearing action between the tire and soil. Its expression is 1 minus v actual by v theoretical, or v theoretical minus v actual by v theoretical. Net traction ratio I have defined. Tractive efficiency is nothing but the drawer power by the axle power. The power which axle gets from the engine. The it suppose this gray part is the axle. This axle is getting some power from the engine, and this tire is developing some traction. This this traction, or it is developing some drawer power. This drawer power divided by the axle power which the tire is getting on its axle is the tractive efficiency. So the tractive performance of any tire, which can be can be uh, can be set on the basis of five parameters: the slip between the tire and the soil, the net traction ratio, gross traction ratio, and the motion resistance ratio, and the tractive efficiency, which is nothing but the drawer power by axle power. So, Sundagiri, tell me what are those five parameters on which we can define the tractive performance parameters. Sundagiri,
Yes, sir.
what are those five parameters on which we can define the tractive performance parameters of a tire?
So that is net traction ratio
Yes,
and slip of the wheel
yes.
or nothing. Travel reduction ratio, sir.
Three.
And
It's not three
tractive
actually.
efficiency.
Sleep and travel reduction ratio is same.
Mm,
So two. It is
yes,
two
sir.
only.
Yes. Gross traction ratio.
Yes.
Also, one more is mm, resistance ratio, sir. Motion resistance ratio.
Yes. You learn in sequence. First is sleep or travel reduction ratio. Second is
Okay.
net traction, gross traction, motion resistance ratio, and tractive efficiency. This ratio term
Okay,
is
okay.
net traction, cross traction, and motion resistance ratio. One is slip or travel reduction ratio, and at last, fifth one is tractive efficiency.
Okay, okay, sir. Last one is start.
Tractive efficiency. Sivaraman,
Yes, sir.
what are the five tractive performance parameters?
Um, Power reduction ratio, net traction ratio, gross gross traction ratio, tractive efficiency, motion resisting ratio.
Okay. If these parts are clear, then tell me the answer of this question. Which of the following sentence given below is correct? Drawer power is mostly used and most efficient. I've summarized the four lectures of that NPTEL series in the all previous slides. Now I will be giving you some questions. I have made 10 questions and you have to solve those questions. Which of the following sentence given below is correct? Drawer power is mostly used and most efficient. PTO power is mostly used and most efficient. Drawer power is mostly used and least efficient. PTO power is mostly used and least efficient. Which one is correct?
The option
See,
C
sir.
is drawbar power is mostly used and least efficient.
Yes, C is the correct answer. So tell me, if contact area of a tire is 151180.32 mm square, cohesion of soil is 11.76 kilopascal, weight is 13.7 kilonewton, friction angle is 22 degree, then what is the maximum thrust the tire can generate? Which formula will be applicable here?
It is AC plus W tan pi, sir.
Yes, everything is given, I think. You have to calculate F max, that AC plus W10. Answer is given. Did you solve it?
Sir, going on, sir. Doing, sir.
Mm,
It is 7.3 kilonewton, sir.
Yes, correct. Third question is, which of the following combination will give maximum deflection of the tire? Which of the following combination will give maximum deflection to the tire? If normal load is maximum and inflation pressure is maximum, if normal load is minimum and inflation pressure is maximum, if normal load is maximum and inflation pressure is minimum, if normal load is minimum and inflation pressure is minimum. What do you think? What is the answer?
Under normal load is maximum. The
Yes.
inflation pressure is minimum, sir. I think so, sir.
Correct, correct. Normal load is maximum. It will obviously give more deflection,
Yes, sir.
and inflation
Get
pressure is
more
minimum.
deflection.
Yes.
Yes, sir.
So the fourth question is, which we were doing on also that time. What overall diameter you got for 13.628 tire? Aspect ratio you take 0.75. 13.6 is the section width in inches. 28 is the nominal diameter in inches. When you multiply 0.75 with section width, you get the height. You multiply by 2, you will get the both height of the tire, and you add with the overall nominal diameter, you will get the overall diameter. You convert every unit in meter, you will get the answer in meter.
Okay, okay, sir.
You multiply 13.6 into,
Into 2, sir.
yes, into 0.75. This you will get section height in inches. You multiply it with 2.54, you will get 51.8. That is the section overall section height, means upper part and lower part.
Okay, okay, sir.
Then you convert 28 inch into centimeter. You get you will get the nominal rim diameter, and overall rim diameter you multiply it with 1.06, as the flange height is not included in that. So when you will do that calculation, you will get. Did you get the answer?
Okay, sir. Doing, sir. Doing, sir. 6.8. Sir, can you please explain once again, sir? So,
13.6 is the section
yes,
width.
yes, sir.
So 13.6 is the section width. So aspect ratio is section width by aspect ratio is section height by section width. So aspect ratio into section width is section height. Means 13.6 into 0.75 is the section height. So did you do that? 13.6 into 0.75?
Yes, sir.
The amount which you got is section height in inches. You multiply it with 2.54.
Okay, sir.
That is the section height
I
in centimeter.
I got. Yes, sir. I got
You
25 point.
multiply it with 2, because there are two section heights. One is the upper part of the tire.
Yes. Upper
Uh,
part and the lower part. Yes,
uh,
sir.
that amount you keep, and for you come to 28 inch. 28 is the nominal rim diameter. That is not overall rim diameter. 28 in 28 is in inch. You multiply it with 2.54, you will
Okay,
get
okay,
it
sir.
in centimeter, because earlier we are doing in centimeter. So the two
Okay,
point you
okay, sir.
multiplied. Then you multiply it with 1.06, because some flange height is not designated on the tire.
0 point
You multiply it with 1.06, so that
1.6.
one overall rim diameter will come. You add that with the section height which we got for the upper part and lower part.
So this is option D, sir.
What did you get?
I I got 1.27 meters, sir.
Yes, that is correct. Answer is D, 1.27.
Yes, sir. Got it, sir. Yes.
So is it clear? It is clear now?
Yes, sir. Yes. Yes, sir.
Actually, I don't have pad right now, and I don't have a scribble pad also.
Yes, sir.
So
Yes, sir. Yes, sir.
I'm not able
Got
to.
it.
Hmm. So the next five more questions are very will clear all your concepts for of this course of the course of first week. So I'm giving you those questions. The first subjective question is you have to calculate the tractive force produced by the tractor wheel. Hello.
Yes, sir.
Calculate the tractive force produced by a tractor wheel that works on a firm soil with a dynamic load of 7 kN. Then the wheel velocity is 3 meter per second. If tractive efficiency is 0.75, what is the power that needs to be transferred to the wheel axle? So there are basically two questions here. You have to first calculate the tractive force uh, which the wheel needs to generate for 7 kilonewton load. Which dynamic load coming on tractor is 7, the weight coming on it is 7 kilonewton. You have to get you have to find the tractive force. Then if it has velocity of 3 meter per second and tractive efficiency 0.75, what power needs to be given to the wheel axle, that you have to calculate. So first calculate the tractive force produced by the tractor. Weight coming on it is 7 kilonewton. So first what you will do, you just tell me the steps. W, dynamic load is W. W is coming on it. Hello.
Yes, sir. Yes, sir.
So what is tractive force? Tractive force is W into coefficient of friction. Mu into W, the basic formula of class 11, physics formula. Mu into W is what? The force generated at the surface.
Yes, sir.
Mu you take. This is a standard table. Mu I'm giving you. From the soil given is firm soil. For firm soil, the standard coefficient of friction is 0.443 to 0.53. When you will take the average, you take 0.48. This is mu. When you multiply it with the dynamic load W, you will get the tractive force produced by the tractor. This tractive force is given by mu into W. So 7 kilonewton into 0.48. You do that.
Yes, sir.
What you got?
3.36.
3.36 kilonewton. This is the tractive
Yes, sir.
force produced by the tractor. Now the velocity of the wheel is 3 meter per second. That 3.6 kilonewton is also written somewhere as draft. In gate examination or somewhere it is written as draft. So this draft into velocity is the drawer power that in general book this is written as drawer power. You have to calculate that drawer power means 3.36 kilonewton into 3 meter per second. Tractive power or drawer power is the pull into velocity. 3.36 into velocity. What is the drawer power you are getting?
10.08.
Yes, 10.08. 10.08 kilowatt is the drawer power and tractive efficiency is 0.75. Then what is the power that needs to be transferred to the wheel axle? What you will do now? What is tractive efficiency? I've described it in earlier slides. Tractive efficiency is the drawer power, this drawer power which we have calculated. Drawer power by axle power, which the question is asking. The power needs to be transferred to the wheel axle. Tractive efficiency is drawer power by the power needs to be transferred to the wheel axle. Tractive efficiency is 0.75. When you will do that, you will get the power needs to be transferred to the axle.
Okay, sir.
Did you get this problem?
Yes, sir. Yes.
So for 13.44 kilowatt at axle, we will design the transmission system accordingly. In transmission, we have some efficiencies, some losses. This needs this 13.44 kilowatt must be transferred to the wheel axle. Second question is, a wheel on a tractor, it is on same line. You can see a wheel on a tractor receives 45 kilowatt from the tractor powertrain. The wheel rotates at 30 rpm if the rolling radius of the wheel is 0.75 meter and the speed of the tractor is 2 meter per second. Calculate the torque acting on the wheel and travel reduction ratio. Travel reduction ratio is also known as slip, commonly known as slip. What is the formula of power coming on the axle? What is the do you know the formula of power? This 45 kilowatt is coming on the, hello,
Sir.
the wheel is getting 45 kilowatt. This is the power coming on the wheel from the powertrain. So power is formula is 2 pi n t. 2 pi n is nothing but the power, formula of power is torque into omega. Omega is nothing but 2 pi n. N is given here 30 rpm. So you can get omega, angular velocity. You calculate the torque acting on the wheel as torque is equal to power by omega, or power is equal to torque into omega. From here you can calculate the torque acting on the wheel. Power is 45 kilowatt and omega is 2 pi n, 30 rpm is given. When you will do 2 pi n, you will get 3.14 radian. It is simple, simple only. 30 by 60 is 1 by 2. 2 cancel, pi radian is coming. So 3.14 radian per second is omega. When you will divide 45 by this omega, you will get torque as 14.33 kilonewton meter. Now you calculate the travel reduction ratio. Can you calculate?
Doing, sir.
Into so calculate the theoretical velocity with the radius 0.81. Theoretical velocity means omega into r. Omega we have already calculated. You multiply it with 2 meter per second. You will get the theoretical velocity. Hello.
Yes, sir.
Theoretical velocity you got 2 pi r omega. 2 pi r,
Omega.
2 pi r n. Oh, sorry, omega naught. Or 2 pi n into r. 2 pi n is omega, which we have already calculated, into rolling radius is 0.75. Omega into r is theoretical velocity. 3.14 into 0.75 is theoretical velocity. And the actual velocity is given 2 meter per second. 2.355 is theoretical velocity and actual velocity is 2 meter per second. With this slip equation of theoretical velocity minus actual velocity by theoretical velocity, you can calculate the slip. 2.355 minus 2 by 2.355. What ratio you got? Slip coming at 15.5%. Are you doing it? Okay, come to next question. Find the distance covered by a tire whose designation is 500 by 65 R22.5. If it makes 12 revolution in 2 minutes on hard horizontal surface with a tire deflection of as 25%. If wheel slip is 15%, then find the actual distance covered. So first you have to calculate the overall radius of the tire. For bias ply tire, earlier we have done. For radial ply, 500 is what? Section width in mm. 65 is the aspect ratio and 22.5 is the nominal rim diameter in inches. You do every calculation in centimeter and tell me what is the overall diameter of the tire coming. 500 is section width in mm. Calculate the overall radius of this tire. Can you calculate it?
Doing, sir. Trying to do.
What you are doing, tell me.
Sectional width 500, sir.
Section width is
And the
500.
65 is the section deflection is the 65 is the deflection.
No, 65 is the aspect ratio. Means section height by
No, sir, sir.
section width.
Sorry.
Section
Aspect
height by
ratio, yes, sir.
section width. 65
Aspect
is to
ratio.
calculate the section height.
Yes, yes, sir.
0.65 into 500 when you will do, you will get section height. Aspect ratio is h by b is 0.65. Nominal rim diameter is 22.5. When you multiply it with 2.54, you get 34.65 centimeter. So the diameter of the wheel without deflection is what? 1.065 or 1.06 into 22.25 into 2.54. Are you doing this?
Doing, sir, yes, sir.
Can you cross check that this diameter which I have calculated is correct? 1.06 into 22.5 into 2.54, then 0.65 into 50 or 500 by 500 in mm, 50 centimeter into 2. Is it coming 125.58 centimeter?
Doing, sir.
From the aspect ratio, height we got 0.65 into 50. So we
Yes,
have,
sir, it is coming.
hmm,
Diameter of the wheel without
is it
deflection.
correct 125.58 this
Yes,
expression?
sir, it is correct, sir. 125 point. Yes, sir, correct only, sir.
And section height, this section height, this part, this is section height. Deflection is del by h. So from here you can calculate deflection. We have what? We have h here. H we have calculated. This 32.5.
Yes, sir.
This 32.5, you multiply it with 0.25, you will get the deflection.
Yes, sir.
This is the deflection that I is getting. And this is the overall diameter. When what deflection you are getting?
Is 8.1.
8.1. Okay. And this is the overall diameter. So what is the overall radius? When you will do divide it by 2, you will get overall radius. What is the radius coming?
62, 62.79.
62.79.
79, sir.
62.7. So you have got overall radius, this radius, and you have got some deflection. Suppose this was the deflection. Suppose. So when you subtract the overall radius with this deflection, means this minus this, you will get the static loaded radius. The static loaded radius is the overall radius minus this minus some deflection. So deflection you got 8.125, and static loaded radius is
Yes.
overall radius minus deflection.
Yes,
It is
54.6.
54.668. This is the static loaded radius. So can you calculate the actual distance covered? This is the static loaded radius, and the distance covered will be what? And in earlier problem we have calculated how we calculate the distance covered. Omega into r. Omega is 2 pi n. 2 pi n is 2 pi into number of revolutions. 2 pi into number of revolution into static loaded radius. When you do this calculation, you will get the distance covered in 12 revolution. This is the distance covered in 12 revolution. Are you getting?
Calculating, sir. Yes, sir, it is okay, sir. Coming, sir.
Huh. So this is distance covered in 12 revolution, but without slip. We have 15% slip also. For slip,
Yes,
what
sir.
we will do? Slip is distance by revolution without load and distance by revolution with load. Then distance by revolution without load. So distance by revolution without load we have. Our slip is 1 minus v actual by v theoretical we also know. So we have theoretical velocity we have calculated we got earlier. So we have to calculate what actual distance. For in formula we have actual velocity as 1 minus slip into theoretical velocity. So this velocity is what? Distance covered by revolution. This is nothing but velocity. Distance by revolution is what? Velocity. Velocity. And we have to calculate what? Distance. So we will multiply the velocity into revolution. This this is the actual velocity. This is the actual velocity. We multiply it with number of revolution. We will get the distance covered. Did you get what I said?
Yes, sir. Yes, sir.
This is actual velocity. The
Yes, sir.
same thing here. This is actual
Theoretical.
velocity, and actual velocity is nothing but distance covered by revolution. So actual velocity into revolution is the distance covered, actual distance covered. Actual velocity into number of revolution is the actual distance covered. So 1 minus slip we have 15% slip 0.15. 1 minus slip we have, and theoretical velocity is the distance covered by revolution. Distance covered without load, a static loaded radius, that what we calculated earlier. This is the distance covered without slip, divided by 12 is the theoretical velocity, and this whole term is the actual velocity. When we will multiply it with number of revolution, we will get the actual distance covered. So what you got, the actual distance covered? 1 minus 0.25 is 0.75 into this 4119.78 by 12 into 12. What are you getting?
It
This
is 308. Yes, sir.
is 3309.82 is the actual distance covered.
Yes, sir.
I think only you are solving.
Currently working it out, sir.
Yes, Sivaram.
Yes, currently working it out, sir.
Okay. We are moving to the next question. These questions are covering all the concepts which we have studied till now. This question is very easy if you have understood the basic concepts of towing and powered wheel. A two-wheel drive tractor is weighing 2500 kg with a weight distribution of 30% and 70% on front and rear axle. Means of 2500 kg, 30% is going on front axle and 70% is coming on rear axle. If rolling resistance of each of the wheel is 4%, means 4% is the rolling resistance of every wheel. You have to calculate the force required to towing the tractor. Means just move the tractor. What is the force required? You have to calculate. Have you understood the question? What you need to do? How will you proceed with this question? 2500 kg, you have to distribute it 30% and 70% on front and rear axle. So you do first 30% of 2500. That amount is coming on the front axle. When you will divide it with by 2, you will get for each of the front axle what the weight is coming. Then you multiply it with 4%, you will get the force required to the rolling resistance of that wheel. That is only the force required to tow the vehicle, which we have discussed earlier, that what is towed force. Without torque, if a wheel is not getting any torque, the force required to tow that wheel is nothing but it is just overcoming its rolling resistance. That rolling resistance is 4% of the total weight coming on it. Are you getting?
Yes,
Hello?
sir.
So weight coming on
Yes,
each of
sir.
the front axle is 2500 into 30% into 0.5 I have done, means half of that. Means 2500 or 30% of that 2500, and then half of that, this value is the weight coming on each of the front wheel. So rolling resistance of the front axle will be what? 4% of that, of this value, then into 2, means here we have divided it by 2, means here I'm multiplying it by 2. This is the total rolling resistance of front axle. Similarly, we have total rolling resistance of the rear axle. This is nothing but the force required to tow. This 30 kg and this 70 kg. When you will add, you will get 100 kg is the force required to move that vehicle. This 2500 kg, if you will apply a weight of 100 kg on the tractor will start moving. This is the basic concept of towing. Did you get this?
Yes, sir. Yes, sir.
Okay. The next question is, if this same tractor whose weight is 2500 kg is used to pull an implement of 3 bottom MB block weighing 250 kg, the weight transfer is 2% from when an implement is attached on a tractor, some weight transfer it gets from front axle also and from the implement also. So from front axle it is getting 2% of the weight transfer, and from rear and from the implement it is getting 10% of the weight transfer. You have to calculate the coefficient of rolling resistance. The concept we have discussed in earlier slides. You have to calculate the coefficient of rolling resistance of each of the rear wheel if the weight distribution is equal among the two wheels. So how will you proceed with this question? You make a tractor. This is the ground reaction on the front wheel. This is the ground reaction of the rear wheel. Weight is getting transferred from the front wheel, and some weight it is getting from the implement. Suppose this is the implement. This implement is transferring a weight of 10%, and from front axle, from the front wheel, there is a weight transfer of 2%. So what is the dynamic weight? It has some its own weight. The tractor is weighing 2500 kg. It has its own weight. From 2% of its weight is coming from the front axle, and 10% is coming from the implement. So what is the dynamic weight coming on the rear axle? Can you calculate? You have to just add its own weight. You have to add its own weight with the 2% of front axle and 10% of the implement. Can you add? Are you adding?
Ah, yes, sir.
2500 kg, 30% was weight on the front axle, and of that 30%, 2% is coming on the rear axle. So weight transfer from the front axle is 2500 into 30% into 2% is 17.5 kg. Weight transfer from the implement is 250, is 10% of 250, that is 25 kg. So what is the total weight? Total weight at that moment means weight transfer from front also, implement also, and its on weight also. Its on weight is 2500 kg and 70% of that 2500 kg. This you will add with the front weight transfer and implement weight transfer. When you will add these three values, you will get 17.92.5 kg. This is the dynamic weight. Now you have to calculate the coefficient of rolling resistance. For that, you need to calculate the rolling resistance first. Rolling resistance is nothing but what? 4%, I think it is given. Rolling resistance was given 4% in earlier question. The question is there. So this is the total weight, and 4% of its this value is the rolling resistance of that wheel. So this is dynamic weight on the rear axle. This is the front wheel. This is the weight transfer from the front wheel, from the front axle. So we have not divided it by 2. This is from the implement. This is dynamic weight on rear axle. When you have to divide it by 2 to get the dynamic weight on the rear wheel. This is on rear axle. When you will divide it by 2, you will get on rear wheel. So, and when you will multiply that amount with 0.04, you will get the amount to tow that vehicle or the loading resistance of that wheel. This is 35.585 coming. Now you have to just divide this ratio loading resistance by dynamic weight, which is the one of the tractive performance parameter which we discussed earlier. Motion resistance ratio, rolling resistance ratio is the ratio of rolling resistance divided by dynamic weight coming on the tractor. This is one of the important tractive performance parameter. You have to divide it 35.85 with 17.92.5 kg. You will get the rolling resistance ratio. Divide and tell me what you are getting. What you got? 35.85 by 17.95 kg by 2. What you got? It is coming 4%. Coefficient of rolling resistance is 4%. Sivaraman and Sundarkiri.
Sir,
So we have discussed 9 questions till now. We will discuss on last question and then we will end our session now. You do this last question. This question is bit lengthy, but it has all the concepts which we have discussed till now. The thrust slip characteristics of each of the two rear wheels in a two-wheel drive tractor are given by this equation. This is the equation of rear wheel, thrust developed by the rear wheel, one of the rear wheel. Thrust developed, the concept of thrust developed by a wheel we have discussed in the first 3-4 slides. So what the thrust is, the thrust the wheel is generating is given by this equation 34 into 1 minus e to the power 1.0.006 s. S is the slip. So F is thrust developed by the rear wheel in kilonewton, S is the slip in percentage. If the PTO of the tractor, if the PTO power of the tractor is 30 kilowatt, calculate the tractive efficiency and power delivery efficiency. Tractive efficiency is the drawer power by axle power. You have to calculate the tractive efficiency. So for that you will have to calculate the drawer power and axle power is given. I think power delivery efficiency of the tractor at the wheel slip of 15%. This 15% you will put this in. You will put in the formula or the expression 34 into that 1 minus e to the power minus 0.06 into s for each of the rear wheel, and with total motion resistance of the tractor as or rolling resistance is given as 2.4 kilonewton. Assume the efficiency of the transmission between engine to PTO. Efficiency of transmission from engine to PTO is 88% and between engine to rear axle is 82%. Calculate the tractive efficiency. First calculate the thrust developed by the tractor. First the thrust developed by the rear wheel. You put this simply put this 15% in that expression, you will get the thrust developed by one of the wheel. Put this 15% in that expression. You will get the thrust developed by one of the wheel as 20.17 kilonewton. This is for one wheel But and for two wheel, you just multiply it with 2, you will get 40.34 kilonewton. And pull is thrust minus rolling resistance. I have told many times in previous slides. So thrust, that is 40.34, and rolling resistance as given in the question 2.4 kilonewton. When you uh, subtract that, you will get 37.194 kilonewton. This is the pull. We have P, F and S, so we can get tractive efficiency as P by F by into 1 minus S as 0.799 or 80%. Did you get it, Sivaraman?
Sir, I'm working it out, sir.
Okay. Did you get the tractive efficiency? Everything is given. P is given, F is given, one is there, slip is given.
Yes, sir, I got it, sir.
What did you get?
0.7994, sir.
Yes, approximately 80% is the tractive efficiency.
Sorry, sir. 0.
Yes.
Yes, sir.
Yes, that is correct. 0.799, approximately 79.99 or 80% is the tractive efficiency. Power delivery efficiency. And tractive efficiency is what? Can you tell? You know that it is written here also, drawer power by axle power. But when we need to calculate the power delivery efficiency, this drawer power will be divided by, and not axle power but the engine power.
Power, sir.
This drawer power by engine power is the power delivery efficiency. So the power delivery efficiency is drawer power by engine power. So you can write it also as drawer power by axle power into axle power by engine power. Did you get what I said? Drawer power by axle power we have. Axle power or tractive efficiency we have. This is our tractive efficiency. Drawer power by axle power. But we need to calculate drawer power by engine power. So we will multiply it with what? Axle power into axle power by engine power. Engine power. Did you get it? This is our tractive efficiency, which you have calculated at 20%. And this is axle power by engine power, which is given in the question. From engine to rear axle, this is given in the question as 82%. You just need to multiply this two expression. This tractive efficiency is 80%. This 82% is given in the question. Or in question it is given that engine to PTO. So it is given. Why, I'll tell you. To have a better understanding, it is given power delivery efficiency is drawer power by engine power. But you have only this tractive efficiency is drawer power by axle power. To convert that equation as drawer power by engine power, you multiply it with axle power by engine power. This is tractive efficiency which you calculated at 80%. and this is the above expression. This axle power by engine power is nothing but PTO power by transmission efficiency, which is transmission efficiency is given in the question also. This 82% is also given, and this 88% efficiency is also given. But you just simply multiply this 80% with 82% and you will get the answer. This 80% into 82%, as PTO power is not given, I think. I think PTO power is not given. Yes. Yes, if the PTO power is 30 kilowatt. 30 kilowatt also you can do well. 30 kilowatt into 88% into axle power you do is also given in question. Then you do it with 80% multiplication, you will get the answer. Or you just simply do 80% into 82%, you will get 65.6% is the power delivery efficiency. Did you get this question?
Yes, sir. Yes, sir.
This was basically a summarizing whole of the week one series of this NPTEL course. If have you watched this lecture series of NPTEL?
Yes, sir. I watched
Mm,
the first 4 lectures, sir. Tutorial lecture, I didn't watch it yet, sir,
the
completely.
tutorial lecture I have with five four extra questions. I have solved all those tutorial questions. So you can if you don't watch that also, you will get you. I have solved these questions here.
Yes, sir. Okay, sir.
So in next week I will be in this 2 hour only. I will be covering the next four lectures in this in the span of 2 hours. That is basically my task. So
Okay, sir.
Sivaram, you are from from starting of this class now. You were there. You joined in the middle, right?
Um, yes, sir. I got 10 minutes late, sir.
Okay. Can you tell what mail you got and when did you get this mail that the class is going on?
Wait, sir. Let me check it out, sir.
When did you get that mail and what was there in that mail?
I got it before 3 days, sir.
Oh, you got this mail from where? Means who sent you that mail?
Through
Who
NPTEL,
is?
sir.
Okay, okay. Can you show
I
that?
got this mail. The mail I got, sir.
Ha.
Okay, sir. Let me share my screen, sir.
Okay.
The screen visible, sir.
Ah, it is coming. Taxation problem solving session reminder. There will be some interactive session with the course team members who explain some same problem, some problem how they are solved. That will help you solve it with this week. We invite you to join the session to get doubts. Okay, but very few students join. Okay, you can stop sharing your screen. So, do you have any doubts or you have got every problems which I solved?
Yes, sir.
Okay, then we will meet on the next session, Saturday 6 to 8 p.m. There I will
Sir, okay, sir.
come with, I will be solving mainly questions only.
Okay, sir.
Okay, bye.